This is another video from CodeWorks. In this tutorial, I thought of discussing bubble sort. Now, bubble sort is not one of the best algorithms. Uh, the reason for it being its complexity is O n square means O n square. Okay. It means whatever be the number of elements, that's this n here, the time to complete the sorting would take n squared times. So if there are 3 elements, it would take 9 units of time. If there are 4 elements, it would take 16 units of time. And similarly, if there are say 10 elements, it would take 100 units of time. It's not one of the best algorithms, but it's still worth learning as an introductory algorithm. One of the best algorithms is merge sort, whose time complexity is O n log n. But I'm not going to discuss this right now. I'm going to discuss bubble sort. As usual, I'm going to use code blocks. And let me first show you how bubble sort actually works. Okay, suppose this is an array here. Let's assume it contains 1 2 3 1 2 3 4 5. Let's assume it contains 5 elements, and suppose the elements are 9 2 1 6, say 10. Now what bubble sort does, it first takes this element, suppose, and finds its correct position in the array. It checks with this element, then if it's greater than this element, these two are swapped, then 9 is in this position now. After swapping, this would become 2 and this would become 9. Just cancel this out. 9. Okay, now it checks this element with 9 like this. It's greater than 1, so we'll again swap. So 9 would come here, 1 would come here. Then it checks 9 with 6. Okay, it's greater than 6, so swap would take place, and 9 would come here and 6 would come here. Then it checks 9 with 10. 9 is less than 10, so it remains in this place. So this is how this bubble sort takes place. Now after this first iteration, 9 finds its actual place in the array, in the sorted array, and 2 is in the first position now. Then we have to find its actual position in the array. Same principle applies, but only difference is that instead of searching the whole array like this from top to bottom, we will exclude the last 2 elements because these are already in their correct sorted position. So we are going to run this array this time up to here. So this is the basic algorithm of bubble sort, and now I'm going to start the coding process. Okay, now I'm going to start the coding process. At first, you are going to save this file as bubblesort.c. I already saved it, not saved, I already made it here, as you can see. Then you just make a file named bubblesort.c and proceed. At first, I'm going to include some basic library files such as include um, yeah, such as stdio.h, standard input output file, header file, then stdlib.h, include stdlib.h. The reason I include stdlib.h is because it's a standard library function and a lot of features of this language are available in this header file. It's worth including. It's a good practice and I advise you guys to also include this header file. Now, in code blocks, there is no concept of void main. It's int main. So I'm going to write int main here. Um, then let's define the array first. Int ar of, let's say, um, 7 elements equal to, let's define the array 9, then 2, then 4, then say 10, then say 1, then say 8. How many? 1, 2, 3, 4, 5, 6, 7. Only one more element left. Let's say 40. Why not? Okay, let's do a semicolon. As you've seen in the algorithm, there are two iterations. Means two loops, actually nested loops. One that goes to find the correct position of the element, and the other one to iterate through all the elements. So there are two loops here, and let's say I name them as I and j. Then int I equal to 0, 0th element of the array. I is less than, here n is 7, I is equal to 7 minus 1, I plus plus. It does not iterate through all the elements because because it checks the next element actually. Okay, I'm just going to show you this thing here, like this. Let's suppose 4 elements. If the element here is some element, say a, then here b, then c. Okay, let's suppose d here. And if the first iteration, not if, in the first iteration b, not b, actually in the first iteration the elements would be checked in this order up to here. Why up to here? Because when this jth element means, and this element, suppose it checks with this, then this, and then it checks with the next element here. And if j had, if if I had been up to here, then it had to check the next element. Is no such element, and an error would be thrown. So it iterates up to this element, means the first 3 elements, not the 4th element. So it iterates up to n minus 1 elements, not the total n elements. Okay, I think it's clear. Okay, let's continue. Then I'm going to initialize another array for j equal to 0. It starts from the top of the array every time. J equal to 0, j is less than 7 minus 1 minus I, because as the loop progresses, at each iteration the elements find its corresponding actual position. So if the loop has iterated one time, one of the rather two of the elements has found the correct position, or one element has found its correct position. So we have to run the jth loop this time from 0 up to the element that already found its correct position. That's why the I comes here. This I term comes here. Then j plus plus. Now, if AR j means the jth element of the array is greater than AR j plus 1. As you can see here, this checking happens um, with the current element with the next element of the array. Now, if this current element is the last element of the array, then when you try to check with the next element, an error will occur because there is no next element in that array, because um, there are n elements and this j equal to n when it comes to the last element. So it's checking nth element with the n plus 1th element. There is no n plus 1th element, so an error would occur. So this loop would run up to n minus 1. So if it's n minus 1, it checks with the next element that's n is present there, and the program would continue and give the proper results. Okay, if AR jth element of AR is greater than j plus 1th element, then we have to swap these two elements. Let's give a temporary variable temp equal to 0, let's suppose. Then temp equal to jth element of the array, jth element equal to j plus 1th element, and j plus 1th element equal to 10. So the swapping happens, and this is it. This is the bubble sort algorithm. This is the bubble sort algorithm. Now let's print the elements and see if we have got our results or not. For I equal to 0, I is less than 7, I plus plus, printf percent d the integer AR subscript I. This would print all the elements of the array. Let's give a space here for clarity. Let's keep our fingers crossed and let's run. Okay, given error, let's see what the error is. It says expected primary expression before int. Okay, this is a mistake. It should be for here. My bad. Sorry for that. Let's run it. Okay, here you go. See, this array is sorted now because it's 1, 2, 4, 8, 9, 10, 40. For you to understand better, what I'm going to do now is print the initial array here. Control plus C. Before sorting, I'm going to print this element, print the elements of the array. Then I'm going to give like this printf give a few line breaks for clarity. After sorting, okay, let's run this. Yeah, before sorting it was 9, 2, 4, 10, 1, 8, 40. After sorting is 1, 2, 4, 8, 9, 10, 40. So this is the bubble sort algorithm. It's really simple, and it's easy to use, but its time complexity is bad. Anyways, it's a beginner's tutorial and I hope you enjoyed it. If you like this video, please hit like and do subscribe for more such videos like this. Thank you.